Hey guys, it's Hazel and welcome back to another ACE Explains video. Today we're going to be working on statistics, which is really exciting. I'm currently taking statistics right now, so I'm hoping that this video will help you guys study as much as it's helping me study. And so today we're going to be talking about frequency distribution and relative frequency distribution. But this is going to be like a simple video about it, and then I'll make another video on how to do it with intervals. So right now we're not doing any intervals. I'm sorry. I can see my hair, that's why I'm trying to fix it. Right now we're not doing any intervals, but in the next video I'll do relative frequency and frequency with intervals, which is really important, and it confused me for a little while, but I kind of finally got it in terms of how to use class width and all of that stuff, so I'll explain that all to you guys. But right now we're going to talk about frequency. So frequency is just a word that describes like how often a value occurs in a data set or data set. Basically, when you have like a data set that's given to you in like a stats question or something like that, and then they ask you to measure the frequencies of each value, it's basically they're trying to find out how often a value occurs in a data set. So it's like finding the mode, basically. I don't know if you remember mean, median, and mode from when you were in elementary school, but it's kind of like finding the mode of a number, except that you're finding all of the numbers' modes instead of just one number as like the main mode. And then relative frequency, which we're going to talk about in a tiny bit. Relative frequency. I'm gonna make sure I spell all these correctly. These are tough words. Relative frequency is basically this expressed as a percentage. So how often the value occurs in a data set, but expressed as a percentage or a decimal. And that is relative frequency. And then relative frequency is most often converted into a pie chart, but it can also be converted into a histogram as well. And we'll talk about those in a little bit. Okay. So when we talk about frequency, these are the types of questions that you normally get when you're talking about frequency. It will be questions that ask you, like I said, to find almost the mode of every single occurring value in a data set. So this question says, that's my red. I'm trying to find a red. Hold on. I have a red highlighter. I'm so sure of it. Okay. So this question says, a soccer team plays 40 matches over a season. Results are wins, losses, and draws. Put this information into a table, which is usually how you will be representing frequency in stats courses, is you'll put the information into a table, and it will show the number of wins, losses, and draws, and then they ask you to calculate the relative frequency. So we need to calculate the frequency first in order to calculate the relative frequency, and we're going to start by creating a table. So here I'm going to have on this side results. I'm drawing my table, results, frequency, and then relative frequency. So this is my table. On the left side, I'm going to have the three types of results, which is wins, losses, and draws, right? I now need to calculate the frequency of occurrence for each value in the given data set. So we'll start with wins. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 wins. And then for losses, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 losses. And then for draws, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 draws. Okay, so that is the frequency, basically how frequently each value occurs in the data set. Now we're going to convert these things, these values, these frequency, we're going to convert these frequencies into relative frequencies. So the relative frequency is the frequency expressed as a percentage or a decimal, or beginning, or before we find the percentage of the decimal, a fraction. So you might recall from studying math that fraction and decimal and percent are all kind of interrelated, right? You know that if you have a fraction that's 25 out of 100, the decimal is 0.25 and the percent is 25%, right? So fraction, decimal, percentage, they're all kind of interrelated. Since relative frequency is most commonly represented as these two values, we need to start by finding a fraction, which will then give us the decimal and then later give us the percent. Does that make sense? So what fraction are we looking for? Well, we already have our numerators here, and those numerators would be the frequency values. But in a good fraction, it always has a numerator and a denominator. The denominator of the fraction is going to be the total amount of matches that, well, actually, let me make this more general. The total amount of values in the data set. So they told us for this question that there's 40 matches over a season, and then we divided that into wins, losses, and draws, right? And so sometimes they'll give you the amount of values, sometimes they won't, and you'll have to count yourself, but you can, of course, count that there's 40 in here. But since we know that there's 40, then we know that the denominator for all of these relative frequencies will be 40. So we start with the wins. We have 15 wins out of 40 total matches, and we put that into the calculator. You're gonna be so embarrassed with me. I don't know where my calculator is. Give me 1 second. Okay, I found it. It's okay, it can be cut out. Anyways, I lost my calculator, but I found it. So, in the calculator, you're going to put the fraction 14 over 40. You probably can't see, but that's okay. And you're going to turn that into a decimal. So the decimal that we got is 0.375. This can then be turned into a percent, 37.5%. Now, the fastest way to turn a number into percent is to use the decimal rule. So we have, what did we have? 0.375. A percent is taking a number out of 100. To divide by 100, you move the decimal place over by 2, 1, 2. And so you get 37.5, and then you add the percent. The other way to do it, if you're not familiar with the decimal rule, is to just multiply your answer by 100 in the calculator, and that will give you the percent as well. Okay, so 37% for wins. For losses, I put 14 over 40. I put that into my calculator. Nice and easy, no rocket science there. I get 0.35 or 35%. For draws, I have 11 over 40. Put that in my calculator. I get 0.275. Put that as a percent, 27.5%. So those are the three relative frequencies for this problem. Wins 15 over 40 or 37.5%, losses 14 over 40 or 35%, and draws 11 over 40 or 27.5%. So those relative frequencies can be represented, as you can see, as fractions, decimals, and percentages, like we have right here. And yeah, so they asked us to put it in the table. We did A, and they asked us to calculate the relative frequency. We got B. So that's all for this question. Okay, we're gonna do another one because why not? This one is a little bit more difficult. So we have a bigger data set here. We have a bunch of colors, and we need to first calculate the frequency. So we're organizing, this says qualitative data. Some people say qualitative data. It's also really important to note that this is also categorical data. Sometimes they ask those on tests or quizzes, like, oh, is this categorical or numerical data? When you're dealing with frequency distribution, it would be categorical data or qualitative, and then numerical would be quantitative. But qualitative data being, qualitative data being how something is presented in a data set. So we're gonna be organizing this data set of colors into a frequency distribution by counting the occurrence of each color, making it into a table, finding the total number of colors so that can be our denominator, and then using that fraction to find the decimal, to find the percent, to find the frequency, the relative frequency. Oh wow, okay, let's do this. We got it. So we're gonna start by making our table. So on top, I'm gonna put colors. I always put titles for the tables. I mean, this is not required, but I like to do that. And a line down the center, right here. And then I'm gonna put frequency in the middle, frequency. And then at the bottom, I'm gonna leave space for the total. Because this time they didn't give us the total. They were not as nice as the last question. So since they didn't give us the total, we're gonna have to work a little bit harder for it, so we have to add. So I'm just putting this line at the bottom to remind me to add for the total. And then here we have the relative frequency. And I leave lots of space for that since that has to do with math. Okay, let's go. So in terms of colors, how many different colors do we have in this question? It's not necessarily about how many total we have. We just want to know how many different colors we have. So I see brown, I see yellow, I see red, I see orange, blue, green. Brown, yellow, red, orange, blue, green. So we have 6 different types of colors. Let's write all of those in the data set. Brown. What is it? Let me see if I can remember. There's red, there's green, there's orange, there's yellow, and then the last one would be blue. Nice, okay. I'm gonna space these out a little bit more since I know that there's lots of space. Okay. Sorry, that's just me, I'm particular. Okay, so we have our 6 colors, and now we of course need to measure the frequency. So we're gonna start at the top with brown, and I'm gonna cross them out using my black marker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 brown. Oh, no one can see that. 12 brown. Let's go with red. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 red. Now let's go to green. 1, 2, 3, 4, 5. 5 green. Now let's go to orange. 1, 2, 3, 4, 5, 6. 6 orange. Let's go to yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 yellow. Oh my goodness. And then lastly, let's go to blue. 1, 2, 3. I think just 3 blue. Okay, and then 3 right here. Let me bring this blue up a little bit. Okay, so we have 12 brown, 9 red, 5 green, 6 orange, 10 yellow, 3 blue. And you're probably like, Hazel, are you sure? I've done this question before. I have the teacher's insight, as in I've already done this question, but yes, I am sure. So that would be, if we add together all of the numbers in the frequency chart, we get a total of, this is lazy of me, I should not be using my calculator to do something this easy, but we get a total of 45 values in this data set. So we have 45 values in the data set. 45 is going to be our denominator as we transition toward calculating the relative frequency. So let's begin. We have 12 out of 45. Now I could use so many different ways to calculate this. I'm using my calculator because I decided it's probably easier. But here, look, 9 out of 45 is the same thing as 1/5, which is the same thing as 0.2, right? 5 out of 45 is 1/9, which is like 0.11 going on forever. 6 over 45, that's hard. It's like 2/15. No one is doing that. Some of them you can use mental math for. Some of them, I'm just gonna take the easy road. 10 out of 45 is like 2/9, which would be like 0.22. Let me see if I'm right. Ooh, I was right. 2/9, 0.222. 3 out of 45 is like 1 out of 15, which would be like 0.06 or something. Wow, I am right. Oh my gosh, that's insane. Okay, that's just me testing my mental math and just proving to myself that I am the genius that I am. Okay. So relative frequency, we found all of the decimals just like that. So we have 12 out of 45, 9 out of 45, and so on. And I just put, right, like I said, the frequency on top of the total, put that in my calculator, as you saw me bragging to myself about me being able to do it over mental math. But I'm still relying on this a little bit. I put the fraction into my calculator, I get the decimal, and now it's time to turn them all into percents. Like I said, you can do this by quickly putting that decimal back into your calculator and multiplying by 100, or you can use the decimal rule. It's up to you. Now you might notice that for all of the decimals that are repeating, I put them in to the thousands place. That's standard practice. Unless it's something like 0.2, which is not a repeating decimal, you should have all of your repeating decimals listed to the thousands place. That's just standard math practice. I don't know why we do that. It just ensures that you get like the most accurate answer that you can possibly get. So our relative frequencies are as follows: 26.7% occurrence of brown, 20% occurrence of red, 11.1 occurrence of green, 13.3 occurrence of orange, 22.2 occurrence of yellow, and 66.7% occurrence of blue. So those are our relative frequencies, and this is a question that we did completely without knowing anything. We were just given all the data set and we had to figure it out ourselves. So if you've been following along with me, awesome job, because this was a doozy, don't worry. I totally agree with you. Here's our last question for today, since like I said, this is just gonna be a light introduction to relative frequency. We will definitely be diving into everything you can do with it in the coming videos. Soam asks 52 people in his school how they traveled to school that morning, records the results in the table below. So we have our travel methods, right? And they already gave us the frequency, which is really, really nice. We don't have to do that as much work as we did with the second problem, but it's always nice to get a little practice. So we have public transport for 12, car, 15 people took a car, 9 people rode a bicycle, and then 16 people walked. All right, so they're asking us to find the relative frequency. However, with a twist, they're asking us to find the relative frequency of 3 different criteria. So let's see if we can rise to the challenge. Letter A says, a student traveling to school on public transport, find the relative frequency. Well, when we look at public transport, we see that 12 people are traveling on public transport. Now, we know that some asked 52 people in total, so we know that our fraction is going to be 12 for public transport over 52, which is the total. And we're going to put 12 over 52 into the calculator. In fact, I'm almost tempted to try this by myself. It would be 3 over, no, my bad. It would be 4 over 14, which would be 2 over 7, a fraction I still do not know. All right, so it would be 0.286, right? And then we would convert 0.286 to a percentage, and so the answer would be 28.6%. So the relative frequency of a student traveling to school on public transport is 28.6%. All right, now let's find the relative frequency of a student walking to school. So that would be letter B. We see walking, 16 people walk. So we've got 16 over 52, which is 0.308 as the decimal, which gives us 30.8%. So the relative frequency of a student walking to school would be 30.8%. And then last, but certainly not least, a student not cycling to school. Whoa. Not cycling, that's not in our table. How are we supposed to solve that? Well, we have to assume that if a student is not cycling to school, they must be taking one of the other methods of transportation. So if a student, this is such a beautiful question, if a student is not cycling, then they must be public transport, walking, or taking a car. Okay, so basically what happened is that the video kind of cut out toward the end of solving the problem. So I just wanted to do this last question justice and finish the final portion. So we're working on part C, which is a student who is not cycling to school. So basically how I explained it is that a student who is not cycling to school must be taking any of the other methods of transportation, which include public transportation, car, or walking, right? And we know from the table what those values are, what the frequency of those values are. And so if we're finding the relative frequency of, if we're finding the relative frequency of a student who does not cycle, that means we need to add these 3 values together. So we have 12 plus 15, and I'm doing this on my calculator. We have 12 plus 15 plus 16, that gives me 43, and then 43 out of 52 total people. So we have 43 out of 52 for our fraction, and I'm putting that in my calculator as well, and that gives me 0.827. And I can turn that into a decimal as well, 82.7%. So the relative frequency of a student not driving to school is 82.7%. Or we can leave our answers as decimal places. Sorry, I just wanted to cut in there and finish off this problem since it cut out for you guys. So yeah. All right, back to the regularly scheduled programming. Now they said give all your answers to 3 decimal places. My bad. I do have all my decimals as 3 decimal places, but I turn them into percentages afterward. Oh well. Make sure you read the question before you solve it. All right, so that is the end of today's video. Thank you all for watching. You all are obviously taking in this content, which I'm really, really grateful for, because I started making these videos in hopes that I could help students the way I was being helped. So hopefully this all makes sense to you, and I will see you with another stats video. Take care, guys.